All right, so we've established that this product gives us the identity. Now we also know that matrix multiplication is associative, which means we can group it any way we want to, and that means that we can group it like this if we want to. As long as we have the matrices in the right order, we just write out the whole product. We can put parentheses around any set of matrices that we want to. So I'm going to put the parentheses around the E4, E3, E2, E1. Now remember, matrix multiplication is associative, so we can always regroup it, but we can't change the order because, as you've done, if you've done everything you've been asked, you've demonstrated that for any variety of matrices, if you multiply AB, you don't get the same thing you get if you multiply BA. Now, if A and B are inverses, you do, but for general matrices, A and B, it doesn't work. Sometimes it does, usually it doesn't. So you can't change the order of these elementary matrices unless you can prove that these elementary matrices are always commutative. That multiplication of elementary matrices is commutative. You can think about that. Okay, prove it, disprove it. Okay, so what we have then is this product, E4 down through E1, this product in parentheses multiplied by A is the identity, which means what? The product in parentheses is the matrix that's inverse to A. So A inverse is this product. If you multiply these matrices out, you'll get the inverse. Okay, now of course we already calculated the inverse, so again, this isn't a good strategy for calculating the inverse. It's easier just to reduce the augmented matrix. But again, we're talking about basically factoring a matrix so that we can understand its structure. You don't know why that's important, but it's really, really important. Okay, and you know, we're laying the foundation for you to understand why and to be able to work with matrices in these really, really important applications. Okay, so there's our inverse matrix in terms of the elementary matrices. So we've got the factorization of our inverse matrix into elementary matrices. Okay, well, that's really neat. Now, let's look at this product. Of course, I'm giving everything away here. The way we did it in class is I wrote this down with no parentheses, and I asked people, is there anything in here that we can group in a way that we know what the product is going to be? Okay? Well, of course, we could group all this because we know that all this gives you the identity matrix, but that's not the point. This would be for any E1 through E4 and their inverses, even if they aren't elementary matrices. What could you group in order to assure that you have a product that you know? And the answer is, and somebody came up with it, you know, you group this. Because E4 inverse times E4 is the identity. Okay? Then you can group the identity with either the matrix on its right or on its left. So somebody said, well, okay, group it with E3 inverse. Okay, we did. Well, E3 inverse times the identity doesn't change the thing you multiply it with, no matter which side you multiply it on. Again, something you should have established by doing problems that verify it. Okay, and I'm a little concerned that not everybody appears to be doing that. Okay, anyhow, E3 inverse times I is just E3 inverse. So we get rid of the I. And now what can we do? Well, now E3 inverse is next to E3, so we can group that, which gives us I. And now I times E2 is just E2, so we have E1 inverse times E2 inverse times E2 times E1 times A. What can you group? Look at it. What can you group here to simplify it? Well, pause until you see it, but it should be clear. You can group this, and you get the identity. And then you multiply that by either this or this, so just, you know, essentially this ends up going away, and you get E1 inverse times E1, which is the identity, so you get the identity times A. So what you end up with is just A. So you continue this process on until you end up with A. So that this product is just A. Now that wouldn't work if you had written these down in the opposite order. because then E4 inverse wouldn't be next to E4, and you can't change the order of your matrices. The first answer I got in which you could group, so I said, well, E1 inverse with E1. Well, yeah, if matrix multiplication was commutative, you'd be able to change the order and get E1 inverse next to E1, so you could simplify that to the identity, but it's not commutative. So you got to do it the way it says here. Anyhow, we verified this equals A. And this means then, of course, since this which is just this is equal to the identity, we can write this product as E1 inverse, E2 inverse, E3 inverse times E4 inverse times I equals A. Okay? And then, you know, multiply I by E4 inverse, you just get E4 inverse, so that E1 inverse, E2 inverse, E3 inverse, E4 inverse product is equal to the A matrix, and there's our factorization of the A matrix. Now it turns out we haven't yet talked about how to get the inverse of an elementary matrix, but it's really easy, so I'm just going to tell you real quick. Let's just take the E3 matrix, which was done by multiplying negative 1/8 by the second row of I2. Okay, well, if you multiply the second row of I2 by negative 8, that'll give you a matrix which, when multiplied by this, gives you the identity, so that's the inverse. The inverse of this matrix is the 1, 0, 0, 8 matrix. And you can multiply this by that matrix and verify it, but we're going to do that more slowly in class. I'm just giving you a preview. So if you don't pick it up from my hand waving and my words, no big deal, but let's try to get the neurons firing just a little bit.
Wait, did you just do like video game reference? Oh my god.
Some mildly profane, fairly loud people in the hall, but they're harmless, so they're fine. Okay, now, but we did, you know, close the door a little bit. To invert this matrix, which is obtained by what? Adding negative 3 times the first row of the identity to the second. Well, we just add 3 times the identity to the second, and we're back where we started. Okay? So there's your inverse. That's how you get the inverse of this type of a matrix. And there's also a matrix, we haven't used it, but where you switch 2 rows, because sometimes you need to do that. Well, you just switch those rows of the identity matrix, and there you got it. So if you switch those 2 rows again, you're back where you started from. Well, that's all actually very easy to understand. You might need me to write it out, or you might need to see a better explanation. You don't have to worry about it right now, but what I'm telling you is it's really, really easy to get these inverses. Once you have these matrices, which is easy enough, you can easily get their inverses. And you can write this down, so now you factored A, and then that can lead us to this cool thing called the LU factorization, which we'll have to talk about next time, because that's all the time we had this time.